I'm David Loveridge. I'm with ICR Engineering in St. Louis. I'm finding it a privilege to be here today and talk to you about PROFINET, and particularly how we use it in the GE system. It's a great privilege to help support GE. And where's the button here? Great. Who we are, we're a systems integrator in St. Louis. We founded in 1993. We've got several engineers. When we combine them all together, we figure we have over 70 years worth of experience in the metals and pulp and paper industry. We're mainly a drive systems retrofitter. We use the automation to control the drives, and our biggest customers are in the metals industry. Some of our customers, our current clients, are US Steel and Cargill Metals, Alcoa, Nucor Corporation, Precoat Metals, and the Material Works. If you're in the metals industry, you'll know that the TMW, the Material Works, has some unique technology to pickle steel or process steel environmentally. So we've been involved in that project. To us, a network matters to an automation system and a drive system because everything has to be connected together. We want to be able to collect the data from the drives, from the PLC, put it into the automation system, and then typically a data collection so that an operator can determine if there's a problem with the machine, or if there's a problem last night, the production manager can look and say, this is what was going on. So it's very important to collect the data right from level 1, right down from the drives, all the way up to the plant complete network. So having one network to collect all that data is a big advantage to our customers. When we look at using a network like PROFINET, it gives us the opportunity to transition from proprietary networks that were installed by different vendors to one common platform, which allows us to connect the safety system and the data collection system and the IT system all on one plant network. So the network of choice when you're doing a new installation or a retrofit becomes of primary importance. This slide depicts our impression of the installed nodes. This is from 2012 data. Raj had mentioned that there's 7 million nodes. We thought that there would be about 4.5 million nodes as of 2012 for Profibus, and PROFINET would be, just over 5 million nodes. We've always used Profibus for our communications networks for drive control, PLC control. So the PROFINET was just a natural migration from the reliability of Profibus. And with the large installed base of Profibus, it was only a natural extension to move to PROFINET. In evaluating what network we would choose for our drive system solutions, we went through an evaluation and looked at the major networks available, being Modbus, Ethernet IP, and PROFINET. And we determined that there was some big advantages to PROFINET. As you can see, safety and control and data collection on a single network, big importance to us, makes it easy to install, and a simple architecture. We wanted to be able to use common off-the-shelf COTS unmanaged Ethernet switches, to be reliable, simple, and non-vendor specific. We wanted a ring topology as far as network goes so that we could have redundancy with a limited number of cables. Diagnostics, very important. Many of our customers don't have a lot of high-tech staff available, don't have an IT department, so they need diagnostics right to the HMI and the data collection system to help them troubleshoot the machine, and that prevents them having to call us too. We wanted a system for I/O control that would bypass the TCP/IP stack, which PROFINET does. Gives us very high-speed control, gigabit Ethernet with maybe 1 to 2 millisecond update on the I/O. So we wanted something that completely bypassed the stack. We also want open multi-vendor support in that we may choose to use the GE PLC, but there may be somebody else's drive that we want to use or another vendor. We like the flexibility of the PROFINET. Gigabit throughput, also important to us for high-speed data collection and high-speed servo control of drives. And we found that the jitter or determinism of PROFINET was better than the other available solutions. So the real time is, shall we say, more reliable. We found that PROFINET was actually easier to install than some of the other Ethernet networks. Being a retrofitter, we have to try to keep the current production line in operation while installing the new system. We try to do that on top of the production. Our customers can't really shut down their lines for 10 days or 2 weeks to do a retrofit, so they want us to do this while they're running. So it's important for us to be able to put something in easily, and quite often we're reusing the same electrical conduits and the same cable runs. So we wanted to be able to find something that would go into the existing conduits easier. We were using the black Ethernet cable below, which is your standard Cat5e Ethernet cable. But the PROFINET cable with the same shielding and what gigabit performance is actually a smaller cable. That allows us to put it into conduits that are already there that may already be full. So a little bit of space does make a big deal to us. We can put a full redundancy in the system by only adding one extra cable. So it makes it a very simple solution to put in and rather easy to retrofit. The other thing that we found with the PROFINET is it's very noise immune. Our environment is a lot of mixed voltages, mixed signals with the drives, particularly big DC drives, a lot of EMR. So we wanted something very noise immune. This is an actual installation of a GE system with the PROFINET. I don't know if you can see the PROFINET cable there, here in the cabinet. But we've had zero problems with PROFINET installations. Noise immunity is wonderful. It just works. So if I look at network redundancy, which is also a big importance to our customers in that they don't want any failures, the PROFINET installation allows us with one simple extra cable to put in a redundant ring. So I can have multiple PLCs, multiple I/O devices all talking together, and if I had a network severed at one point, the ring will keep operating, and it will report back to the master that there's a broken ring. It'll tell me which node is having a problem, and I can go and make the repair if necessary. The other thing with this particular architecture is we didn't need to have multiple power sources to make the system operational. We could use one power source per each node as opposed to other architectures that require two power sources for redundant nodes. In the metals industry, safety is a big concern these days. OSHA rates, EMR rates need to go down. So with a retrofit of a new control system is a perfect opportunity for improving safety. The PROFINET network allows us to put a safety system in with the automation system and use one network, simplifying the installation, of course, reducing the costs. So we can go all the way from a light curtain or any safety device into a safety PLC and network back to our master control PLC, all one network. And it's TUV SIL level 3, so very safe. And we can network all the way up to the HMI and report on the safety system as well as report on the I/O. There's also a TCP/IP channel available for data collection, a slower, not as time-critical collection, so we can do management of the I/O and management of the system and collect all the data over the TCP/IP channel, which is traditional for the IT people. On a recent application, our customer specified to us that he wanted something that was easy to maintain in the event of a node failure. Earlier technologies required him to do reprogramming of I/O blocks in the event of an I/O failure, and his biggest specification to us was, I don't want to do any programming. So we looked at available technologies and found that the GE PROFINET installation would allow us to replace a node, and it would auto-reconfigure. If you're replacing only one node at a time, it will auto-reconfigure, and there's no programming required. A big deal to our customers, again, with limited maintenance people, limited IT people. It points them right to the node, and he can replace it. One of our recent projects where we used PROFINET was for Cargill Metals in St. Louis. They have a cut-to-length line that was old technology, and they just couldn't maintain it anymore. The old electronic equipment was failing. We're finding that many of our customers are going through the same situation. The control system is just becoming obsolete and parts aren't available, so it's time to upgrade and have something that's maintainable. Cargill was in that situation, and they wanted a safety system to improve their safety on top of their control system. They needed motion control to tight tolerances. This is a cut-to-length line, so it extends a coil and it cuts it to a certain length within a 32nd of an inch is their requirements. And they wanted something that was very easy to troubleshoot, and we could collect data on top of the HMI system. We could collect data so that the operators could look for trend problems. We were able to put this system in with zero downtime, the new system. We used available downtime, I should say, weekends and things like that. We didn't have any scheduled outages to do this project. We migrated from the existing multi-network system to a common PROFINET system in a matter of a few minutes, actually, after we had the cables installed. We were able to achieve 100% improvement in cut length accuracy by having a high-speed network in there. And the maintenance manager at Cargill had said to us that he needed something that he could configure without any programming. He could replace a block without ever having to do any programming. And that's where our specification came from. Some additional benefits of the PROFINET network that we put in that we really didn't expect was it was easier to implement than we ever thought it would be possible. Our network was up and running in 30 minutes for the whole line. Once it was installed and the cables tested, the whole network was commissioned in 30 minutes, which that really sped up our schedule. We've had no issues whatsoever with the communications or the I/O or any hardware on this line at all. It's just worked reliably, and you don't even know the PROFINET is there. What's it mean for our future if we standardize on using PROFINET and GE? It's the ability to connect up into the cloud, enabling data and improving operational productivity. What I mean by that is I can get data right from the level 1 I/O device and the safety system and bring it up into a data collection system and then even populate that on the internet so that the corporate people could monitor their machinery, could monitor it right down to the I/O point and find out which proximity switch or which RFID sensor is not operating correctly and report that over the cloud to a remote operation, and they could call the maintenance people, say, you need to change this device. As the life cycle of industrial controls decreases, the ability to upgrade systems becomes critical. With proprietary networks, a customer has had to stay with a specific vendor if they wish to migrate, if they wanted to use the same network. PROFINET has enabled us to use the best from every vendor available and also build a network that we can use in the future. Technology is changing very quickly these days, and the life cycle of a product is rather short. as opposed to 20 years for the older PLCs. Now it's 5 or 6 years, and that people are being forced to upgrade automation equipment more frequently. By using PROFINET, we can depend that that network will be supported for a long period of time, and it's an open standard, so it minimizes the engineering effort required to change out a component in the future. We believe the Ethernet PROFINET is here to stay. And thank you very much.